So in the last session, we discussed. I'll request you guys to please turn off your camera if anyone is turning on the camera. Yeah, thank you. Yeah. So we're going to discuss in this session about how you can configure your networks by using different mechanisms. I hope we discussed about class C, class B, and class A subnetting, and I made you familiar on how you can like use packet tracer. So the software that you're gonna use inside of this training is going to be Cisco Packet Tracer. Let me share my screen quickly. And there you go. I hope you all can see my screen. And I'm gonna start a software which is Cisco Packet Tracer itself. There you go. Now, in this software that you can see, I'll give you a quick, I would say, overview of how the software actually works. And I believe I told you the same in the last session as well. But we have this main toolbar over here, which is kind of something that gives you an ability to select a topology, to delete some object from that topology, be it router switches or something, in order to delete something, and in order to design anything according to your topology requirements. Okay, so that's kind of a main toolbar that you have here, and then you have like a menu option, which is about creating a new topology, opening up a new topology, saving a topology, printing a topology, right? And then we have copy paste options, we have undo redo options, zoom in, zoom out options, and we have some other options over here. But the main section but the main function that you need to like make yourself comfortable with is this over here. So these blocks here kind of ensure something that the first row is I would say the like various type of network devices. So you have network devices, you have end devices, you have components of them, you have cabling standards, then you have some miscellaneous devices and some WAN devices. And if you click on some or the other type, then the second row changes accordingly. So if I click on network devices, these are the type of network devices that you have. You have a router, you have a switch, you have devices like these. And when I select a router, then in the next column, these are various, I would say, options that we have in order to choose or in order to see that how, like what are the routers models that are available. And then if we click on switch, then you can see that switch as well has various models over here, right? Just like that. Then this particular section over here might be hidden. Okay, so this might be whenever you install the packet tracer by default, then this might be the scenario that you would see, and you will not see, I would say, a result window. So you need to enlarge that particular window by clicking on this arrow button over here at the very corner. So when you click it, then you will see your result window where whenever you transfer some traffic, then you see the output whether the traffic went successful or not over here in this window. And this is how the dashboard over here looks like. This empty area, the white space that you see here, is nothing but the topology area. So we're going to build our topology over here itself. Now, I told you about how you can like use the basic topology. And when I say that if I take a router and a switch and try to build up a network, then here you go. So I can go to the network devices section, then I can go to the router section, and from this router section I kind of drag out. Yeah, I hope I become more audible like this way. So if you want to create a topology there, then in that topology you can say that the router that you need to select from this list is PT router. Okay, this PT router over here. And we use this PT router because we have enough number of interfaces that is built in into this PT router. And the way that we need to select it, it's just by dragging it over here. So you can drag this particular router like this. And if you want to delete it, you can just click on this particular delete button and it will ask you, do you want to delete the selected item? Say yes, and the router is no longer available there. And then you can press an escape button to get out of that particular delete mode. And then if you want to put it again, then you can say PT router can actually be placed over here. Make sense? Now, just like that, we also want some devices, let's say a switch. So a switch can be selected by going into the switches section here. And then when you click on that, you can drag this 2960 series switch, okay, over here into the topology. And just like that, you can also drag some other devices, be it end devices. So with the switch, we want to connect around different PCs together. And when you say click on end devices and then click on PC, and you can drag these PC over here, and you can drag the laptop over here as well, like that. And once you have certain devices ready, even like more PC or so, then what you can do is you can actually, I would say, connect all these devices together by selecting a cable. Okay, so when you select a cable, now here's the thing. We have different types of cables that are available. And if I talk about Ethernet standards that you have, then you can say Ethernet standards. The first Ethernet standard that you have is Ethernet itself. And whenever you have Ethernet ports or Ethernet, then the speed of that particular Ethernet port is 10 Mbps. Cool. Then the second, I would say, type of standard that you have is fast Ethernet. And the speed of that fast Ethernet is 100 Mbps. Okay. And third, you have gigabit Ethernet. And the speed of that gigabit Ethernet is 1 Gbps. And if you talk about the fourth one, then you have 10 gig Ethernet. And of course, you might have guessed the speed of that is Gbps. Okay, it's megabit, not byte. I've written the small b, right? So it's megabit. And if we talk about the cables, then there are different type of cables that are available. One is copper cable, and the other one is, I would say, fiber cable in order to send. And copper also has certain standards into it. So copper, you can say STP, which is shielded twisted pair cable, and you have UTP, which is unshielded twisted pair cable. And if you want to check that, you can open up your browser and you can see that as well over here. Unshielded twisted pair cable. And this unshielded twisted pair cable looks like this. So this is kind of a cat 5 or cat 6 cable, which is actually something like this. So you will have 8 different pins over here having different colors. Okay, you will have green, white, and green, brown, white, and brown, orange, white, and orange, and then you will have blue, white, and blue. Okay, so you twist them together so that there, I would say, electromagnetic interference when the data actually travels from those cables doesn't like create like collision with the other data that's also traveling over there. Okay, and then if we look at the shield, like the comparison between shielded and unshielded, so this is how the comparison looks like. The shielded twisted pair cable is like has a I would say a shield of aluminum foil around the pins that are there. The number of pins and every other thing is just same, but the only difference over here is it will be shielded. And why it would be shielded? Because there are two ways, or there are two platforms or infrastructure we actually need to use these cables in. We need to use it outside our buildings or whatever infrastructure you have. Whenever an ISP gives you a cable, then ISP needs to carry that particular cable and lay it over the city to make it reach out to you for providing you the broadband connection, right? And that particular cable that the ISP uses is actually called a shielded twisted pair cable. But the other cable that you use inside of the infrastructure, be it in a building, be it in a lab, or be it in any environment, we call that particular thing as unshielded twisted pair cable. So the shielded twisted pair is used in a scenario when you actually need to like shield it from the atmospheric challenges. Okay, be it summer, be it winter, be it rain, it will face all those things. But the unshielded twisted pair cable is not that strong. That's why we use it in home environments or office environments. Okay, and this is expensive one. So even when you use this shielded twisted pair cable or unshielded twisted pair cable, there are even types in that. So and the other one is of course fiber. So if I show you the optical fiber cable, and you can see that this is how the optic fiber looks like, right? So you'll have kind of an optic fiber cable, and then this particular optic fiber will actually have a core where the data travels with the speed of light. That's why whenever you're talking about a pretty fast internet, you need to go for the fiber optic cable, because that is something that provides you the faster data over there. Make sense? And if we look at like the types of copper cables that you have, then you can create something in a way that is called as straight through cable, straight through copper cable, and the other option that you have is crossover copper cable. So if you look at straight through copper cable, we use this straight through copper cable in different devices. And when we have, I would say crossover cable is basically used between same devices, which means is if you have router at the one end, and like if you have switch over here and one switch over here as well, let's say like this scenario. And if you want to connect both of these together, switch 1 and switch B, then the cable type that I'm going to use is going to be crossover. But if I want to connect this particular switch with the PCs or with the router, then I'll be using, I would say, straight through cable. So that is a rule over there because of some connectivity things that it needs. Because when we look at the copper cable, then the Ethernet segment only uses 4 pins out of the 8 pins available in a copper cable, and out of which 2 pins are used for forwarding and 2 pins are used for receiving the data. And same is happened or same works over here with the fast Ethernet as well. Only 4 pins are used. But if you talk about the gigabit Ethernet, then gigabit Ethernet uses 8 pins. All the pins will be used for sending and receiving the data. And in the 10 gig as well, it will use all the 8 pins from the copper cable in order to send or receive that particular data from one location to other location. Okay, but in Ethernet and fast Ethernet standard, only 4 pins are used for sending the data, and other 4 pins are used for voltage supply. But in gigabit and 10 gigabit Ethernet, all the pins will be able to send the data as well, and they will be able to give the voltage supply as well over there. Makes sense? Then, okay, if you're facing some issue into the, I will share my screen again, don't worry. And there you go. I've shared my screen again, and I hope you all can see my screen now. So that's exactly what we were discussing about, that how Ethernet standards are created, how the cables are. And the only logic that you need to put up or understand is whenever you are using same devices, the cable type will be crossover. But whenever you're using different devices, the cable type will be straight through. But this is now old stuff. There is something called auto MDX. Okay, auto MDX. Now, what is this auto MDX? This auto MDX is basically a feature that almost every device now has it turned on. And the requirement of this particular feature is the duplex setting needs to be auto, and the speed setting of the interface also needs to be auto. Make sense? Now, when these settings are set up and your auto MDX on the device is on, which is by default on most of the devices, then you don't need to worry about the straight through cable or crossover cable because it will be automatically identified. You get that? So then you can use any type of cable in order to connect from one device to other device, be it straight through and be it crossover. If you connect a straight through device in a desired crossover scenario, then the cable will behave as a crossover. Okay, if you connect a crossover cable in a straight through desired manner or straight through desired type, then it will automatically use straight through over there. So you don't need to worry about that which type of cable actually needs to be used for what kind of scenario. It is automatically taken care by with a feature called auto MDIX. Then after that, so we over here, as we have our topology with us ready, then in this particular topology, what we are going to do is we are going to connect all these devices by going into this connections window. And inside of this connection window, yeah, if you are connecting a PC with a router, then you can use crossover cable. Of course, you can use crossover cable, but you can use straight through as well. There is no need to be specific about these things in today's world. It is automatically taken care by. Now over here, if I want to connect all these devices together, what I'm gonna do, I'm gonna click onto the first cable which says automatically choose connection type, and this is one of the cable that actually represents the feature of auto MDIX. So I'm gonna select this cable, and then I'm gonna connect my R1 or my router with the switch like that, and I don't need to specify anything over there. Then what I can do, I can select another cable and say connect this and connect this like that. But you see, every time you need to connect some devices, you need to go into the uh, window over there and you need to select the cable. So there is a shortcut that you can use. Is you can press. I'll delete these cables as of now. And what you can do is you can press Control button on your keyboard and then you select this particular cable. And it happens with every devices. Let's say you want to place 10 routers over here. So if you do it one by one, you need to go onto the router section and then you need to place one device, then one another device, then another device like that. But instead of that, what you can do, you can just click Control onto your keyboard, and then after clicking Control, you can select this PT router. And once by clicking the control window, when you select this device, you can leave the control button and then just click for whatever amount of time that you want. And for the amount of time that you're going to press the enter button or the click, then for those many instances the devices will be placed over there. Make sense? Just like that, you can do the same thing with the connections as well. You can go onto the cables, you can press the control button, and then you select the cable. Then you leave the control button, and then click and click, click and click, click and click, and click and click, and then you press the escape button once you're done. Do you understand that? So this is how you actually make use of that particular shortcut. So that's exactly how we're gonna use it. Now the network that we're gonna create for this scenario, we can create a note of that by using this note utility. And I can say over here that the network that I want to create is 192.168.1.0/24. Now you see, when I'm saying over here that I want to use 192.168.1.0/24, it means that the range that I'm gonna have is gonna start from 192.168.1.0 and it's gonna end up at 192.168.1.255. And if I talk about subnet mask is going to be 255.255.255.0. You understand that? So when you have such scenario, you can see that the first IP address, of course, will be the network ID, and the last IP address, of course, is going to be the broadcast ID. Okay, so the usable range or the valid IP over here is going to be 192.168.1.1 to 192.168.1.254. That is what is going to be the usable range, and out of which we are going to assign the very first IP address to the FA0/0 interface of the router, which is 192.168.1.1. And switch will not get any IP address because it's a layer 2 device, so it doesn't require any IP address. It just works with the help of MAC addresses. And then the PCs will get the IP addresses, be it 1.3, 1.4, 1.5, accordingly, whatever they're supposed to get. Make sense? Do you understand what I'm trying to say over here? Please respond into the chat. Perfect. All right, let's move ahead with the next thing then. That after having this IP address configured over here, how are we gonna do that? Now, can you see that the packet tracer represents two different type of topologies or two different type of analogies here, which says that the range over here or the cable over here is red. It means that the connection is red, and then you can check that the switch and the PC's connection is green. Make sense to you? So when we have this scenario over here, it means that the interfaces that we are using between the router and the switch are turned off. And if you look at the interfaces that are there between the switch and the PC, the interfaces are green there, which means that the interfaces are up and they are ready to forward the traffic. Now here's the thing. For whatever devices or for all the devices that we have here, all these devices of Cisco uses an operating system of Cisco, which is called as Cisco Internet Working Operating System, which we call it as iOS. It is not the iOS of Apple, but yeah, we also call it as iOS. So this Cisco iOS that is loaded onto the devices that we actually use. And these devices are managed by something called command line interpreter, okay, which we call it as CLI. So if I want to do anything on this particular device, I need to use Cisco's iOS, and we make use of the CLI commands or command line interpreter or command line interface. You can better call it interface. It's interface itself. Yeah, command line interface in order to make any changes to your topology. You get that? Now, how do you make changes? Here's one thing. Whenever you kind of create a topology, then I would suggest you not to do the practical when I will be designing something. I would please request you to pay your attention, okay, to my explanation, because it won't be possible for me to repeat I would say to repeat the concepts again and again. So I will give you enough time after my explanation to do the lab, like I have given you the time to perform subnetting practice during the class, and I'll be sitting there to solve your questions when I ask you the question. But if when I'm explaining you, if you are too busy in following my lab along the way, then you won't be able to understand the concept, and then you will be asking me the doubts that please repeat and so on. So okay, so when I explain you something, you put your packet tracer on hold and pay attention over here. And then once I get done with the lab, then I'll say, now this is the time that you do the lab, and then you do the lab. Okay. Till then, you make your notes. What I do, okay, you note down if you need anything to be noted down over there. This kind of helps me to keep the class in flow. Cool. Now you see, so when you are going to install your packet tracer, you might not, upon creating a topology like this, you might not be able to see the interface names that I see here, which is FA0/0, FA0/1, and all the other interface names here, right? So what you need to do is you need to go to the settings of your packet tracer by going into options and preferences. Over here, I have some different settings, but yeah, you might have an options window over here. And inside that options window in Windows machine, you can click on you can click on settings or preference. Over here, I'm going to preference like this, and then such window will open up. And once you open this window up, you need to make sure that always show port labels in logical workspace is checked. If this is unchecked, then if you say, like, if you close this thing, then you see I also won't be able to see the names of the interface that I'm using. So what you need to do, you need to go to the settings of your packet tracer by going into options and settings, and then you need to click on this always show port labels in logical workspace. And then you can close this particular thing down, and then you will again start seeing the interface names there. Cool. Yeah, options and preferences, and then always show port labels there. Thank you so much, Aman. And then you, so after you become like good with the topology design, then in order to get the command line interface of the device, you click on that particular router, and when you click on the router, you will be getting, I would say, a window like this. Over there will be certain tabs. You will have a physical window, you will have a config window, CLI window, and attributes window. So to do any modification onto the device, you need to click on the CLI window here, okay, which is command line interface. And once you click on the CLI window, there you go. You will start seeing the CLI here. Now here's the thing. When you actually look at the CLI, then the very first thing after the image boots up, it asks you that would you like to enter the initial configuration dialog. And what you say there, you say no there. And then once you say no here, it says press return to get started. So return means press enter key in order to get started over here. Now, to get started, what you need to do is when you say that in the command line interface, you need to understand there are three modes. One, you have a user mode, okay, which is actually represented with a greater than sign, or you can just say, yeah, greater than sign. Okay, for example, like this, R1 is going to be the name of your router and then greater than sign, and like this. Then the second mode that you have is enabled mode. And this enable mode is also called as user privilege mode or privilege executable mode or so or so. But usually we call it as enable mode. And this enable mode is going to be represented with a hashtag. For example, like this, the name of the router followed by a hashtag. And then the third type of representation or the third mode that you have is global config mode, global configuration mode. And this global config mode is represented with config in bracket with a hash. For example, like this, R1 and then in bracket config and then bracket complete and then hash, like this. So these are three different modes that you have inside your command line interface, okay, or inside your operating system. So when you have these three modes, what you need to do is you at the beginning you will be in user mode. Then in order to go into from user mode, you need to go to enable mode. And then from enable mode, you need to go to global config mode. And if you want to come back again, you need to go from like global config to enable and then enable to user mode. This is how the hierarchy works. You cannot jump off directly from user to global config. It's not possible there. So when you have the CLI over here, it says press return to get started, right? And when I hit return there, then you see the name of the router followed by greater than. You can hit enter button for how many number of times that you want to hit. And then you can say, in order to go to the enable mode, you say enable and then hit enter. That's how simple it is. So to go from user mode into the enable mode, you need to go into the, just a minute. Yeah, so to go from user mode into the enable mode, you use a command that is called as enable. And then after that, in order to go from enable mode to global config mode, you use a command called configure terminal. And there you go. So you see how the mode and the representation changes with the name of the router here. So you say router greater than sign, and then you also have hit the enable command, and then the mode changes, and then you use the configure terminal command in order to go from enable to global config, and that's how the mode changes. Now you see, in user mode, we actually just use this user mode command for doing the very basic troubleshooting. Okay, you will hardly be using the user mode in order to do anything into the CCNA class. But then after that, when you actually go to enable mode, this enable mode actually is used for verification and troubleshooting purposes. So you can use all the show commands, you can verify your routing tables, you can verify your VLAN tables, or your running configuration, or specific configuration, interface configuration, all these commands, or all the current configuration and the saved configuration can actually be checked into the enable mode, because it supports set of show commands there. And then after that, you go into the configure terminal mode, which is actually used for deploying any type of configuration there. Make sense? So enable mode and global config mode are the modes where we are going to play a lot. So after coming into the global configuration mode, you are free to do any kind of changes over here. The very first change that we want to do to our router is rename our router. And how do you rename that particular router? You rename the router by using a command called host name, and you give it a space, and then you specify the host name that you want to rename your router with. So let's say I rename that particular router with R1 underscore pynet. Okay, you cannot use spacebar for naming your router. You cannot use any you can say spaces between the different words that you're using for naming your router. Just like that, I have used R1 underscore pynet, not space pynet, and I hit enter, and you can see the name of that particular router has been changed. Do you understand what I'm talking about? Please respond. Perfect. So over here, after you kind of rename your router, then there is one thing that we need to do. So according to our topology that we have here, what we need to do is we need to, you see, there are multiple interfaces. So you can get the statistics of every device that you have by hovering the cursor over that device. So if I take my cursor over there, then you can see that on the statistic window, you can see that there are list of interfaces that we have. Then on the next column, you see the link status. On the next column of that, you see the IP address configuration and so. So when you have the list of interfaces, you see that it's fast Ethernet 0/0, you have fast Ethernet 1/0, serial 2/0, serial 3/0, and fast Ethernet 4 and 5. And every interface there by default is down, and there is no IP address that has been configured on those interfaces. So according to our topology that we have, we need to go into the FA0/0 interface, and we need to turn that interface up, which means we need to turn that interface on. And then after turning that on, we need to configure IP address on that interface. Make sense? And how do you do that? So you go into the global config mode of the router. You again click on that particular router to get the CLI access. And then as you are inside the global config mode of the router, you use something called interface command. So we say interface space, and then you give the name of that particular interface. Someone is saying, yeah, I'll try to do that. Yeah. So you say interface space FA0/0, or you can say fast Ethernet 0/0, right? Because there you go. Now here's one thing. If you want to be familiar with Cisco's operating system more and more, then there are helper utilities as well. Like how do you know, or how will you get to know that which commands can you actually use, or how do you come up with the syntax of that command? So Cisco introduces something to you called question marks. And if you are in any mode, you can actually make use of the question mark. You see, I was into global config mode, and then by using exit, I came out of that particular mode to the enable mode. Then I again used exit, and then from enable mode, I went completely out of that router into the user mode again. So when I say hit enter now, I'll be into the user mode. Now, I don't know what all are the commands that can actually be used on this user mode or in this user mode. So what do I do? If I want to get the list of all the commands that are supported in this mode, I will just use a question mark over here. Do you see that? So after I placed question mark, these are basically the list of commands that you can use in order to like do your work at the user mode. So you can use connect command, you can use the session number to resume, you can use open a terminal connection, you can disable, you can disconnect, enable, exit, log out, ping messages, resume, show messages, right? Show running system and SSH, telnet, terminal, and so on. So all these commands actually can be used from the user mode. The one that we need to use is enable, which actually turns on the privilege executable command. And then we say enable. Now we didn't even know, or we don't even know that what command does, like, is it a complete command, or do we need to use anything apart from that as well with that command? So in order to get to know that, you can again like type your command over there, give it a space, and then say question mark again. And once you say question mark, it also asks you that what is the enable level that you want to do. Otherwise, if you don't know that enable level, then you can go in, you can like also hit the enter button. And CR is what indicates that there is nothing. It's fine if you don't enter anything after that, you can just hit enter. Okay, so I'll say enable and then hit enter. And then after hitting enter, enable levels is nothing something that you need to know about as of now. So just consider it as you can hit enter after that. And then when you click question mark again, then this question mark is going to give you the list of all the executable mode commands, which means the commands that can actually be used in this mode, which is auto, clear, clock, configure, connect, copy, debug, delete, dir, disable, disconnect, enable, and every other thing. Make sense? So that's how you can get to know about the commands that you need to use. And then after that, I say, like you see, I need to go to the config mode, so enter configuration mode. So I will use over here configure, and then I don't know what do I need to use after that. So it says terminal. So I'll say configure terminal, hit enter, and there you go. You are inside the global config mode. Now here also, if I don't know anything about the list of commands that you need to use, I can use question mark, and then you're gonna get all the configure commands that are gonna be here. And as we need to do the interface configuration, you can see select an interface to configure. So I'm gonna specify here interface. Now here's another thing. If you type down the command partially and you don't know the spelling, you don't know what do you actually need to type here, then you can just simply press tab button, and then this tab will automatically complete the command for you. This is how Cisco's operating system kind of helps you. But this will only work only if and if like there is only one command that you can use which starts with int. Like there is no ambiguity with this particular command, right? Int, because there is only one command that starts with int. But if I say, let's say if I just say I and then press tab, you see nothing happens, because there are multiple commands that are available which starts with I, and the device is not able to understand which I or which command are you referring to with by just using I. So you just need to complete that particular command, and as I say IN and press tab, it automatically said interface. Make sense? Do you understand what I'm trying to say? Perfect. Then after interface, what command would you use there? So you can give a question mark here as well, and it will give you an option that you can use interface dialer, Ethernet, fast Ethernet, gigabit Ethernet, loopback serial, virtual template range, and so. So the one that we need to use is fast Ethernet, as we are looking forward to go into this interface. So we say interface FA0/0, right? And after you go into the interface, you see the mode of that particular router change. And then over here, you can see that after FA0/0, then you say, in order to turn the interface on, you need to use a command called no shutdown. And as soon as you hit enter button over here by using no shutdown, then you will see some log changes, and then you will see the interface became green now. And you can also hover your cursor over here, and you see the fast Ethernet FA0/0 link is up now. But still there is no IP address that has been configured on that. So how do you do that? You basically again go to the CLI, and after using interface FA0/0 and no shutdown, then you use a command called IP space address. And by using IP space address, what you need to do, you need to specify the IP address that you want to use, which in our case is 192.168.1.1. And then you give a space and enter the subnet mask as well, which is 255.255.255.0. There you go. So you can also see that it prompted it pointed out the error that you have, that I'm using double IP. That's why the command was not accepted. So by using the upper navigation key, I can go to the last command, and using the left navigation key, I can come at the very starting of this command. You cannot use mouse cursors over here to play with that. You see, if I even click over here, the pointer shows it's over here, but as soon as I type something, it goes back to where it was. So the mouse pointer doesn't work here, and I'm gonna like only the keyboard navigator keys will work. And then I fixed that particular command and I hit enter, and there you go. It didn't give any error. And you can again go back onto the statistic, hover your cursor onto the router, and you can check that the FA0/0 has been configured with 192.168.1.1/24. Make sense? And then the interface is up and everything is running here. Now, if you want to verify the list of interface that you have over here as well from CLI, and not because in real environment, you're not going to have any GUI that will give you the statistics. So what you need to do here, you actually need to use something that you can take an exit from there and come back into the enable mode. And you can use a verification command in this mode that says show IP interface brief. Well, switches all interfaces are up by default. Okay, Rishabh, you need to turn on the router's interface because routers, every interface is into different broadcast domain. So by default, it's off, and it needs like more power consumption. That's why you need to make it like on. But it is like participating into different broadcast domains. So that's why the router's interface or all the interfaces are off, and you need to make them on, and then you can select that which interfaces do you actually want to work with. So when I go into the enable mode, then I can use a command that says show IP interface brief. And as I hit enter, you can also see the same output over here, that these are the list of IP address, like list of interfaces, and the IP address configured on them, and then the status. Okay, so it says up, up, and the others are administratively down. And then you hit enter, and then after that your router configuration is complete. Now we don't need to do anything on the switch yet, so we just need to assign the IP addresses to the PCs that you have so that they can communicate together. So how do you do that? You basically click on the over here onto the PC, then from the PC you can click on desktop section, and then once you click on desktop, then you will get all these options here, and you can click on IP configuration, and then you hit over here the IP addresses that can be 192, then 168, then 1.2, and then you press tab there, and it will automatically get the subnet mask configured. Then you can close this PC, you can go to the next PC, go to desktop, go to IP configuration, and say over here IP address as 192.168.1.3, and press the tab button, and then done. And then you can close the IP or close the computer section, then go to again desktop, IP configuration, and press the IP over here as 192.168.1.4, and then you hit the tab button, and then you can close it. And then if you hover your cursor onto these PCs will also notify you that the IP is configured as 1.2/24. Then on the second PC, you have 1.3/24, and you have 1.4/24 on the laptop. So that is how you basically configure a basic topology. And then in order to make sure that the communication between them is working, you can select a message from here. Okay, this is basically something that says add a simple video. So you can click on this message, and then you can like click on the PC from which you want to initiate the communication, and then you can click on the other PC where you actually want to send the traffic, and you hit enter, and there you go, the communication was actually successful. You can verify that over here. Just like that, if you want to select, if you want to send traffic between some other devices, select the cable, select the message again, click on the source, click on the destination, and there you go, successful. PC1 to laptop 0. If you want to send traffic between this PC and the router, you can click the source and destination, there you go, successful. Make sense what I'm talking about? Yeah, perfect. So go ahead, try the simple lab that we actually did. I'll write down the commands that we use. Over here, we on our router commands, we use interface, or we first went into enable, and then we said configure terminal, and then we said interface FA or 0/0, no shutdown, and we said IP address 192.168.1.1 along with the subnet mask. That's all the command, and then we use a verification command that says show IP interface brief. So use this command, build up your topology and see if it works for you. I'll give you 10 minutes of time. Okay. Till then, consider it a break if you're done, and then we'll move on with the next topic after that. Thank you. Yep. I hope you all are done with the lab. All right, moving on. Next thing, we're going to explore something that is called as DHCP. And most of you have heard about DHCP, which actually stands for Dynamic Host Configuration Protocol. Cool. And this dynamic host configuration protocol does the work of provisioning IP addresses and other parameter information, be it gateway, be it DNS, or be it some other thing, uh, by using DHCP protocol itself. So what we are going to do now, we are going to place a couple of more end devices to the switch that we are using. And then we are going to configure the IP addressing parameter on those devices, not by using manual configuration, but by using DHCP configuration there. So how do we do that? There are just a couple of more commands that we actually need to add, but I'll again do the entire thing again, okay? Because some of you might have missed the configuration that we have did. So what we're gonna do, I'm gonna restart this particular device. And how do I do it? I can go onto this particular router and I can go to the enable mode and then I can say restart. Oh, it's not restart, it's reset. Okay. So when you say reset, oh, okay. It's reload, yeah. Neither restart nor reset, it's reload. So when you say reload, and then it asks you whether you want to save the configuration that has been modified. So I say no here, I don't want to save the configuration, and I hit enter. It says proceed with reload. I say yes, and then it again starts to decompress the image. And there you go. The device is up again. It asks you, would you like to enter the initial configuration dialog? I'll say no. And now again, what we are going to do now, we are going to add some more devices to it before we configure the router. And over here, I'll place another PC and another laptop. So I select the cable here and then connect it with the same switch that we have. Just a minute, guys. Yeah. So after placing the couple of devices here, I go to you see the interface has again become down here. So we need to turn on the interface configured with the IP address and provision a DHCP configuration there. And how do we do that? We basically go to the enable mode, go to global configure mode by saying configure terminal, and then selecting the interface by saying interface FA0/0 and saying no shutdown. And then you see the interface is coming up. The switches interface, however, takes some time to start. So from red, it has become, I would say, amber or orange. And from orange, in some time, it will become green. So we're going to talk about why this process happens when we will discuss about layer 2 switching, or we will discuss about spanning tree protocol. But yeah, for now, you can see that the router's interface has become green now. So after it becomes green, you can go ahead and configure the IP address by saying IP space address 192.168.1.1 and space 255.255.255.0. And then after that, what you need to do is you need to create a DHCP pool. There can be multiple DHCP servers that can be configured on your router because your router has the ability to, I would say, handle multiple networks. So what you're going to do here, we're going to create a pool. Let's say the users that we have connected belong to a sales department. So I'll create a pool with the name of sales by saying IP DHCP pool sales. Okay. And you can see that the mode of my config has been changed to DHCP config now, not the interface config. So by doing this, I say IP DHCP pool sales. And then after that, I need to define what network do I want to specify the IP addresses of. via this DHCP. So I go into the DHCP pool settings, and I then say network space the network ID. So we say 192.168.1.0, which is the network ID of the network that we're using. And then along with that, you need to specify the subnet mask. So we hit enter here. And then after that, I say default hyphen configure, default hyphen router, and then give the IP address of the router that we have. Okay, so we say default hyphen router 192.168.1.1, hit enter. Now what this default hyphen router is going to do is it's going to configure all the other PCs with, so the network command is going to configure the endpoints of the PCs with the IP address and the subnet mask. But along with that, it will also provide default gateway configuration information to these routers. Makes sense? So the PCs will be configured with IP address, subnet mask, and default gateway. And the default gateway over here will be 192.168.1.1 because that's the one that we have specified. So we entered over there, and then we take an exit from that particular thing. And then what we can do, because our PCs already have the DHCP, the static IP addresses configured, we can select the PCs that we newly have added, and then we can click here, go to desktop, go to IP configuration again, and then say DHCP. And you can see it's requesting IP address, and then it should get, okay, it failed out, and then we again say DHCP, and there you go. The DHCP request was successful, and it says the IP address has been assigned, which is 192.168.1.6. Then we have 255.255.255.0, and we have default gateway configuration here. Just like that, if I go onto the new laptop and then go to desktop and say IP configuration and DHCP, then you can see that it has received 1.7 along with the other IP parameter. You can even go onto the previous PCs which are already having some IP addresses. And instead of saying static, you can click on DHCP and they'll also get some IP addresses there. There you go. 1.8. Then you have 1.9, and you also have 1.10. So you see, this DHCP pool keeps on assigning the IP addresses sequentially to the number of requests that are being actually given. Makes sense? So DHCP internally communicates or works by using different messages. You have D, which stands for, or DHCP works, DORA process. And this DORA stands for, D stands for discover, O stands for offer, R stands for request, and A stands for acknowledgement. So if any particular, I would say, user, or if any particular PC tries to request a DHCP address, then initially the discover message is sent onto the broadcast address. Then after that, the offer message, like once a DHCP server gets that discovery message, then it sends an offer to the user who is requesting that DHCP. And then once the offer is received by the user and it is accepted by the user, then the user gives a request, which is actually a DHCP request saying to the server that, hey there, I want to take that address. Please provide that address to me. And then the acknowledgement is given containing all the information. So this is how DORA process actually works for assigning the IP address by using DHCP. Okay. So what you need to do now over here is we're going to work in a way that you need to configure something, you can say a topology for me, which is going to be like this. So you need to take a router, and then you need to take another router. You need to take a couple of switches. Okay, and then you need to also take a couple of PCs over here. And what you're gonna do, you're gonna connect all these devices together. Like this. And the network that you're gonna configure over here is 192.168.10.0/24. And you're gonna configure 192.168.20.0/24 here. And the requirement over here is both the routers should be up and the PCs should receive the IP addresses with the DHCP configured on them, not the statically. So these are the two networks that you need to configure. And then once you do that particular lab, then we are going to go ahead and configure something called static routing. And we will make these two network communicate together by using that. So go ahead, try this particular thing, the IP config and the DHCP for these topology, and let me know when you're done. I'll give you another 10 minutes for that. Thank you. Hey there. I hope most of you are done. Okay, I'll show you guys how you need to do this configuration. So you see, we created a topology which was like this. And you actually wanted, or I actually wanted you guys to configure this topology by configuring the IP and DHCP settings. So what we're gonna do, I'll go on to this particular router first, and then inside of this router, I'm gonna go on CLI, and I'm gonna say no here because we don't want this configuration to be done. And then after that, what I'm gonna say, enable, and then configure terminal. Then interface FA0/0, no shutdown, and IP address 192.168.10.1 along with the subnet mask. And then after that, you create a DHCP pool by saying IP DHCP pool, let's say A here. And then we'll give a network ID of 192.168.10.0 along with the subnet mask like this. Now there is, okay, yeah, like this. And then we say default hyphen router 192.168.10.1. Make sense? Then after this, what we are going to do, we're going to go on the another router, which is this. And on this router, we're going to configure a network that is 192.168.20. So I'm going to go into the CLI, and then I'm going to say no, enable, configure terminal, and interface FA0/0, no shutdown, IP address 192.168.20.1 along with the subnet mask. And then we say IP DHCP pool B, and then network space 192.168.20.0 along with the subnet mask. And then we say default hyphen router 192.168.20.1. And that's exactly how you come up with the DHCP configuration for both of these networks. Then I can click on each of this PC individually, go on to the desktop section and IP configuration, and click on DHCP. And there you go. The IP is configured from 10. Then over here, the IP is configured from 10.3. And this should be 20.2. There you go, 20.2. And then you'll have 20.3 here. Sounds good. That's exactly how you basically configure it. Now, the requirement over here is the requirement over here is I want you to make something in a way that you want the people from 10 network to communicate with the people from 20's network. So let's assume that a PC is initiating a communication from this PC, and then it needs to go on to this PC. So how would the communication happen over here? So in order to do that, you also need to connect both of these routers together, right? And you do that by connecting it with a cable. So you take a cable and then you connect this router with the other router. Let's say this is our R1 and this is our R2. Okay, I'll also name them by going over here, taking an exit, and I'll say host name is R1. And then I'll go on to the other router and say host name is equal to R2. You see that? The IP, the names has been changed. Now what I want is when the PC tries to communicate, or when the PC wants to communicate from here to here, then the packet will actually be sent onto the router. Then router needs to decide that it needs to send the traffic to R2. But it will only be able to send the traffic from R1 to R2. Okay, we need to create a subnet here. So we'll create a new network and we'll say this network is 192.168.30.0/24. And let's say we will provide an IP of 30.1 here, and then we will provide an IP address of 30.2 on the other end. Make sense? So for doing that, you need to go into the R1, you need to go into SE2/0 and say no shutdown and provide an IP address of 30.1. And you need to go onto the R2, turn on the interface SE2/0, and then configure an IP address that is 30.3 or 30.2. Sorry. So you go onto the router and then you say interface SE2/0, no shutdown, IP address 192.168.30.1, correct? And then you say 255.255.255.0, and then on the other end you say interface SE2/0 again, say no shutdown and IP address 192.168.30.2 and 255.255.255.0. Makes sense? Why 30.2? Because you can check the interface over here. You can check the interface over here that we are using. It is 30 dot. It is SE2/0 here, and over here as well it is SE2/0. So that's why the routers by default uses serial interfaces in order to get connected together. So these are serial interface. You can see if I go into the router and click on the physical, and then if you check that, if I zoom in, you see over here, these are the interfaces that you have. So these interfaces are the fast Ethernet interfaces that you have, which is FA0/0 and FA0 slash I would say 1. And these two interfaces are serial 2/0 and serial 3/0. And the other two are basically the fiber interfaces that you have. But we're not using those anymore. Makes sense? So we say interface SE2/0 is being used for the communication between both of these routers. And once I configured these IP addresses on both of these interfaces, then you can see the link between them again became green. So if I hover my cursor onto R1, you can check that my FA0/0 is configured with 10.1 and my SE2/0 is configured with 30.1. And if I go on to the R2 and check the same information, you can see that my FA0/0 is 20.1 and SE2/0 is 30.2 there. So when I click on R1 and go to the CLI and try to ping to the R2, does it works? So I can go on this, I can go onto the enable mode and say ping 192.168.30.2 and hit enter. There you go. The exclamatory mark indicates that the communication was successful, and you can see that the success rate is 100% there, which means the ping message was successfully delivered. You get that? So as of now, if I see, then I have 192.168.10.0, then I have 192.168.20.0, and I have 192.168.30.0. These are the three networks that we have in the topology. Do you guys have any question over here? Do you understand it? Perfect. Now, as we want to, I would say, implement some static routing. And when we say static routing, what do we mean by it? Is the communication between two different networks needs to be done over here, from one network to the other network. So we have 1.0 and we have 2.0 here. Yeah. You connect two different routers by using serial interfaces. So when I'm doing that particular configuration, you can check that from R1, So here's the thing. Every router maintains something called routing table. And routing table actually is the brain of the router, according to which it forwards the traffic. So the only job that the router has got is to forward traffic from one location to other location by using the best route that is possible. And for every route that exists into the topology, your routing table should be updated about that. Otherwise, if the route is not present into your routing table for the destination, then the traffic will not be sent. Okay? Yeah, you can call that as V.35 cable as well. If I try to send traffic from PC3 to PC6, then currently the communication will be failed, even though everything is green. When I even if I even try to send traffic from here to here, it will not work. Why is that? Because the router is not aware about the other route that is there. You see, so there are two type of networks that we have. When we consider two type of networks, the first is called as directly connected network, and the other one is called as basically indirectly connected network. Make sense? So, what is directly connected network and what is indirectly connected network? The networks which is actually connected to the router, it's called as directly connected network, plain English, right? But if you have a network in the topology about which the network actually exists, but it is not connected with your router, it will be called as indirectly connected networks. And I was telling you something about routing table as well, right? So routing table is basically a table where all the information about the networks that the router knows about is maintained. And you can check the routing table of individual routers by going into the enable mode and by using a command called show IP route. When I use this show IP route command, I'm gonna get the list of all the networks that my router currently knows about. You see? So these are different codes. I've used a command that says show IP route, which is used in order to get to know about the routing table of the router. And you can check that these are all the protocols that are supported onto the router. And then you can see the routes as well. So currently my router only knows about 192.168.10.0, and it knows about 192.168.30.0 as well. Make sense? But if I check about R2 and if I run the command called show IP route, just a minute, guys. Yeah, sorry about that. So if I check about the information over here that says do show IP route, then you can see that the other router knows about the directly connected network, which is 192.168.20.0 and 192.168.30.0. And then after that, if you look at the indirectly connected network, the R1 doesn't know about the other network, which is 20.0, and the R2 doesn't know about the first network, which is 10.0. You can check the routing table of both the routers over here. You can see that the R1 only knows about 10 and 30 network, and the R2 only knows about 20 and 30 network. So you can say that 30 is kind of a common network that you have, that both of them knows about. But R1 doesn't know about 20 and R2 doesn't know about 10. And that's why if I try to send traffic from this PC to this PC, the PC actually checks whether it knows about the source IP and the destination IP that is going to be given into the IP header. Does it know about it into the local routing table? Then the PC finds out that there is no information about the destination network in my local routing table. So what does it do? It considers that destination network for unknown network, and it forwards that all the unknown network traffic to its default gateway, okay, which we have configured over here as 10.1, which is our router. So indirectly, the router will receive all that particular traffic over here onto the router. Now, the router will check in its routing table whether it knows about the source and whether it knows about the destination. And it checks for this information into the routing table that it maintains. And after getting to know about that, then it will decide that on which of its interface it needs to forward the traffic. And then based on that information, it will forward the traffic ahead. But as of now, you can see that whenever I'm trying to forward traffic from this PC to the other PC, it's getting failed. Why so? Because whenever the traffic is being received by the gateway is checking the routing table and it gets to know that it doesn't know about the destination network, which is 20. So static routing, when we say we are implementing static routing, it means that we will statically inject a route in our routing table about 20.0, and in R2 we will inject a route about 10.0 in our routing table. Yeah, so over here, when we actually do you understand, guys, the concept of static routing? In static routing, we are going to inject specific route into the routing table of our router, and by considering that route, it will be able to forward the traffic from one location to other location. So how do we do that? Now, as our entire network is configured, because this is the prerequisite, right? Your network should be configured with all the IP addressing schemes, and all the I would say interfaces needs to be up there. Then what we are going to do, we're going to tell about 192.168.20.0 to R1, and 192.168.10.0 about about 10.0 to R2. And how we're going to do that? We will go on to the R1, and we will go on to the configure terminal, and then over here say IP space route space 192.168 dot I would say 20.0. So I will specify the network ID of the indirectly connected network there, and then I will give it a space and then say subnet mask, and then give it a space, and then after that what I'm gonna say is we need to specify something called exit interface. So understand what's exit interface. On this router, when the traffic is going to receive, it doesn't know where the destination is actually situated. Make sense? The only thing that it knows about that if I want to send traffic to 192.168.20.0, okay, gosh, man, my screen is already shared, and you can try reconnecting it or reconnecting with the session if you're not able to see my screen. Yeah. So when we say that if I would say I want to add the static route, then I want to mention over here after saying IP space route 192.168.20.0 and 255.255.255.0, I need to mention something called exit interface. Now, when the traffic will take an exit from R1, which interface is it needs to take an exit from? It's SE2/0, because this is the interface that is facing towards R2, where the destination is. So we go over here and we say SE2/0 and then hit enter. And just like that, when I use this particular command, I can again verify my routing table by saying show IP route, and then you can see that there is a new static route that has been added, which says 192.168.20.0. You see this S indicates that it's a static route. Make sense? And just like that, I will go on to the other router, and you can check that there is no static route as of now. But then I'm gonna say IP route 192.168.10.0 along with the subnet mask, and then the exit interface on R2 as well is SA2/0. So over here I say SA2/0 and then take an exit. And then after that, if I show you show IP route, there you go. You have another static route that says 192.168.10.0, right? On the other side, you have 192.168.20.0. And this is how you update the static route information into the routing table of your routers. And now that both of your router are aware about the networks that they're connected with, then I can try sending traffic from this PC to this PC, and it will be failed for first time because of the ARP resolution process that the router does. And then after that, it's gonna make that particular communication successful. So I'll again try to send traffic from here to here, and there you go. Now it's successful. And then if I send traffic from here to here now, first time it's gonna fail, and then it's gonna successful. Make sense? Soumya, yeah, you can give next hop IP address as well, but this concept is not, I would say, recommended anymore. So I'm not gonna discuss about that. I will please suggest you to use the exit interface itself to be specified over there. Yeah, thank you. ARP is basically address resolution protocol about which we're going to discuss. ARP is used in order to figure out the MAC address from a given IP address to get to know about the physical location of that. So the first packet is failed in the simulation for the ARP resolution, but in real time, you will hardly notice that. In real time, all your packets will be delivered quickly over there. Make sense? So this is how the configuration has been done. Okay. And then, yeah, let's take a break for 10 minutes, I would say, and then try to do this particular lab. ARP is not automatic request protocol, it's address resolution protocol. Okay, take a break for 10 minutes and then you can try this particular lab. The only command that I'm going to mention over here is the static routing command. The command is IP route 192.168.1.0. Oh, sorry, 192.168.20.0 space 255.255.255.0 and SE2/0. That's what the static routing command is. So take a break for 10 minutes and try this particular topology and see if your PCs will be communicable with each other. Okay. And then I'll give you a different lab there. Thank you so much. Take care of yourself. Yeah, hey there. Yes, Nelson, we need to do it in both routers. Yeah, you can configure IP address, or you can configure DHCP on both the I would say routers, but that's nothing that we are exploring as of now. But you can do it, yes. Yep. Yeah, I'll explain later. Don't worry. Redundancy protocols are gonna come later in this course. Cool. Now we're gonna look into something, or there is something that you need to do. Is we're gonna extend the routing, static routing scenario over here, and we're gonna do it by having multiple, I would say, routers here. So let's say I'll bring up a topology, which looks like this. And then we have a couple of PCs that are connected here. And we have your connections that are made up with 4 different local area networks. But there's going to be a tweak, or you can say challenge, in this topology. And then what you're going to do is this. Yeah, exactly like that. So the networks that you're going to have is 192.168.1.0/24. Then you have 192.168.2.0/24. And you have 192.168.3.0/24. And 192.168.4.0/24. And then after that, you have 192.168.5.0/24. You have 192.168.6.0/24. And you have 192.168.7.0/24. So how do you configure it? The only challenge that you have here is, you can say that if we look at the perspective of R1 and if we look at the perspective of R4, then these are the edge routers, or these are the routers which only has single exit interface there. Okay, and if you look at the perspective of R2 and perspective of R3, you have multiple exit interfaces. You have SE2/0 facing towards R1, and you have SE3/0 facing towards R3 on R2. And on R3, you have SE2/0 facing towards R2 and SE3/0 facing towards R4. So when you consider adding the indirectly connected networks, which how many can you tell me how many directly connected networks does R1 have? Can I say there are just 2 networks? And same for R4 as well, right? Yeah. But if I look at the perspective of R1, how many indirectly connected networks does R1 have and R4 have? Can I say for R1, 2.0, 3.0, 4.0, 6.0, and 7.0? All these networks are indirectly connected networks for R1. And then for R4, we have, I would say, 1.0, 2.0, 3.0, 5.0, and we have 6.0. So all these networks are basically indirectly connected networks for R1 and R4 respectively. So you will be adding all these indirectly connected networks into R1 and R4's routing table statically. And then If you look at R2, R2 has three directly connected networks, which is 5.0, 6.0, and which is 2.0. But you see, when you will be now 1.0, 3.0, 4.0, and 7.0, all these networks are basically indirectly connected networks for R2. But when you will add a static route for 1.0, then the exit interface will be SE2/0 because that's the direction where the network needs to go through. And if when you will add the information of 3.0, 4.0, and 7.0, then you need to, I would say, use an exit interface of S3/0. Make sense? So exit interface kind of is critical information that you add up into the configuration when you configure static routing. Do you understand what I'm trying to say? Vincent, if you remember something that when we use a command of static routing, you see, over here you can check the scenario that in this IP route command, we are using exit interface as SE2/0 because that's where we want the traffic to go whenever there's any traffic for the destination of 20.0. In similar cases, if you add the static route on R1 for 2.0 or 3.0 or any network that we have, the only exit interface that R1 has is SE2/0. But if you consider R2, then R2 has different networks situated with different or situated with the reachability of different interfaces. Yeah. It is advisable or it is advised as the best design practices to use next hop IP, to use exit interface in comparison with next hop IP addresses. Okay. So the best design practices say that use next hop like exit interface and not the next hop IP address. So when we actually consider this, just a minute. When we actually use it, then what you need to do is while adding the static route for R2 and R3, you need to consider the network that you're gonna add and the exit interface where it can actually be reached for. Okay, so this is one of the, I would say, thing that you need to focus on, and I want you guys to work on it and make sure that you are able to configure. So the task for you in this particular practice is configure all the IP addresses first, then make sure that the Ethernet networks get the IP addresses via DHCP, then connect all the serial networks, okay, with the IP addresses of their network. You can say 5.1, 5.2, 6.1, 6.2, 7.1, 7.2, and then implement static routing. And then after that, each of this particular PC should be able to communicate with each other. Sounds good? So I want you guys to first try this thing. Okay, take your time. Around 20-30 minutes will be required to do this particular practice, and then I'll show you how you can work with it. Sounds good to you all? By this way, you will be able to understand the doubts in your mind and the questions by yourself. And then I'm gonna show you the configuration by myself, and then all your doubts again will be cleared up. Perfect. Go ahead, try this particular topology and see if it works. I would request you to not extend the last topology because practice is something that we emphasize on. So create a new topology, and this will kind of make you better in terms of getting to know about the CLI and so. Go ahead, try this thing and see if you get done with that. Okay, and then I'll show you the lab. Thank you. Yeah, all right, guys. Time's up. So now I will show you how the configuration can actually be done. And in that, we're going to start with a very basic thing, which is about configuring the IPs. So I'm going to go into each router and I'm going to configure the fast Ethernet IP addresses and the serial interfaces that we have here. Sounds good? So this is our going to be R1. I'm going to say no here. Enable conft hostname R1. Then interface FA0/0, no shutdown, IP address 192.168.1.1 along with the subnet mask, and then IP DHCP pool A and network 192.168.1.0 along with the subnet mask and the default gateway configuration. Correct? Then I'm going to take an exit from that mode, switch the interface to SE2/0, say no shutdown there, and IP address 192.168.5.1 here. Just a minute. Let me put my Mac on charge. Yeah, there you go. So after configuring the IP address on SE2/0 as well, then we're gonna move to R2, and we will also ensure that the DHCP config onto the devices are okay. So here we go, and then there we go again. Right? Then I'm gonna go to R2, and on this R2, you're gonna say no, enable configure terminal, then hostname R2, interface FA0/0, no shut, IP address 192.168.2.1 along with the subnet mask, and then IP DHCP pool B, network 192.168.2.0 along with the subnet mask, and then default router 192.168.2.1. That's all. And then we switch the interface to SA2/0, no shutdown, and say IP address 192.168.5.2, right? And then we will change the interface to interface SE3/0, say no shutdown, and IP address 192.168.6.1 along with the subnet mask. Correct? This is the configuration that we're gonna do for R2. Then I'll get the IP address configuration onto the end devices, and we're good. There you go. And then we are going to move next to R3 now. And on the R3, we'll say no here. Enable configure terminal interface FA0/0, no shutdown, IP address 192.168, then 3.1 along with the subnet mask, and then IP DHCP pool See, network 192.168.3.0 along with the subnet mask, and the default hyphen router is going to be 192.168.3.1, and take an exit there like that. And then we're going to switch our interface to SE2/0, configure an IP address over there that is going to be 192.168.6.2 along with the subnet mask, and interface SE3/0 with an IP address of 192.168.7.1 along with the subnet mask, and take an exit. Correct? That's going to be the configuration IP config for third router, and then we're going to go and check whether the IP is up or not, and boom, and there as well. Yeah, we're good. And then we go on to the last router and say no, enable configure terminal, say interface FA 0/0, no shutdown, IP address 192.168 4.1 along with the subnet mask. And then you say IP DHCP pool D network 192.168.4.0 along with the subnet mask, and default hyphen router 192.168.4.1 along with the no subnet mask required there. And then we take an exit and configure the SE2/0 with the IP address of 192.168.7.2 along with the subnet mask. There you go. So you can check that the IP is up and all the interfaces are green. And we'll go on to the PC of last network and should expect an IP address of 4.0 subnet. There you go. Desktop IP configuration and the Dhcp. Cool. If I verify that by hovering the cursor onto each router, you can see that on R1, FA0/0 is 1.1, SE2/0 is 5.1. On the next router, we have 2.1, 5.2, 6.1. Then we have 3.1, 6.2, and 7.1. And then on the last one, we should have 4.1 and 7.2. There we go. All good. Any questions till now? Do you guys understand what we did? Perfect. Now we're going to add the static routes. So on R1, as I already have told you, we need to add 5 different routes, right? And everyone would be facing towards SE2/0. And the routes are going to be 2.0, 3.0, 4.0. Then we're going to have 6.0 and 7.0. So going on R1, and I'm going to say IP space route 192.168.2.0 along with the subnet mask and SE2/0. Boom. And we have 3.0. We have 4.0. We have 6.0. And we have 7.0. And take an exit. And there you go. So I can verify my routing table like this. And you see 1, 2, 3, 4, 5, 6, 7. All the routes are there into the routing table. 2 routes are directly connected and rest of them are static routes. Then we're going to move on to the R2. And in the R2, we're going to add 1.0 facing towards 2/0 and 3, 4, and 7 facing towards 3/0. So I'm going to say configure terminal IP route 192.168.1.0 255.255.255.0 SE2/0, and then I'm gonna say 192.168.3.0 255.255.255.0 SE3/0, and then 4.0 and 7.0. Right, and then we can check the routing table by saying show IP route, and here you go, 1, 2, 3, 4, 5, 6, 7. And then if I go and verify or do the configuration on 3, then of course 1, 2, and 5 are going to be via 2/0, and just 4 is going to be via 3/0. So here we go, IP route 192.168.1.0 255.255.255.0 SE2/0. Then you're gonna have 2 with the same and 5 with the same, and you're gonna change it to 3 for 7.0 network. Makes sense? And then I can say show IP route, and there we go, 1 2 3. Oh, there is no 4. There is no 4 because the last route that we added, it's a wrong information. So we need to change this particular route. We didn't need to add 7.0 network, and instead of that we needed to add 4.0. So I'll remove that particular route by saying no IP route 192.168.7.0 and SE3/0, and then I'm gonna add 192.168.4.0 and SE3/0. There you go, and say exit show IP route. There you go, 1 2 3 4 5 6 7. And then on the last route we're gonna add everything by saying IP route 192.168.1.0 F255.255.255.0 SE2/0. Then you're gonna add the same for 2, the same for 3, the same for 5, and the same for 6. And then you can take an exit and say show IP route. You see 1 2 3 4 5 6 7. Now when you have such kind of scenario, then you can see all our routing has been implemented. And then if you try sending traffic now that all our network is segregated and configured, I can send traffic from here to here. The first packet is going to fail. If you double click on this particular packet, it's going to resend that. So double click. There you go, successful. If I send from here to here, first packet failed, double click, successful. Then from here to here, first packet failed, double click, successful. From first to last, successful. Do you understand that? Yeah, this is for learning purposes. We're not going to implement bus topology in the production environment, of course not. But yeah, I need to take such references so that you'll be able to compare it with the star topology or some other type of topology there. So do you understand, guys, how did we work through this? Perfect. Okay, so this was actually something that we had to look into. In today's session, we saw how basic configuration can actually be done. We got, I would say, introduced with the Cisco's CLI, command line interface. Then we also, yeah, you can get the PDU without clicking on it just by using P. So you see, the shortcut key for that is P. So when I actually say P, it gets selected. Perfect. In tomorrow's session, we are going to talk more about how default routing works and how different scenarios actually works over there. Okay, in the same topology itself, and we will talk about some of the limitations of static routing and see how load balancing and all those other things go. So there are two different types of static routing which we have to explore now: default routing and floating static routing. We're going to talk about that in tomorrow's session. I hope you enjoyed today's session. Do practice a bit on this particular concept and make yourself more familiar with the CLI. Okay, and I'll see you guys tomorrow on the same time. Till then, take care of yourself. I hope you enjoyed the session. You're going to get the recording soon as it gets uploaded onto the drive. And yeah, practice a lot. Thank you so much for joining. I'll see you guys tomorrow. Take care of yourself. Bye-bye. Yeah, thank you.